All right, guys, got a quick little refresher of logarithms. This is logarithmic form right here, and this is exponential form, little memories from last year. Logarithmic form, you can see all of these problems here are in logarithmic form because they have the word log with them. Let's refresh our memory on some things. We've got the base of the logarithm, which is this little subscript down here. We've got this weird thing, the argument, and this guy over here is called the exponent in this case. All we're doing on this first little bit of practice here is taking this from log form and rewriting it in exponential form. So exponential form always looks like this up here in the corner. The base raised to the exponent equals the argument. So our base is 2, the exponent is 3, and that will equal the argument. And I hope you realize that that's a true statement. Like totally 2 cubed is 8. If we go to number 2 here, to rewrite it from log form into exponential form, we take our base, which is 3, this little bitty guy right here. He's going to be raised to the exponent, which is that's 6, and that should equal 729. Doing it again here, from log form into exponential form, 4 to the second equals 16. And this guy right here, the base is 3, the exponent is 2, and that should equal 9. Please try number 5 and number 6. Give it a shot. Pause the video. All right, 4 to the negative 4th should have been 1 over 256. And 10 to the negative 2nd equals 1 over 100. This is taking stuff from logarithmic form because all of these had the log in it and rewriting it into exponential form. Let's do the reverse. Let's take it from exponential form and bring it into logarithmic form. We will need to bring the word log into this scenario, and then we'll put our little subscript of the base, which is this 4 right here. Then the argument comes next to this, and see this guy, he is the exponent. I usually say like the exponent gets exiled on one side of the equal sign. When you put it in log form, the exponent is all by himself on one side. So I need to bring a log in this one. The base is 5. He's the guy that's being raised to a power. Then the argument of 125 comes next, and the exponent gets exiled in that case. So log base 15 of 3375 equals 3 in that case. So the exponent gets exiled. On 10, log base 27. The argument is 3, and the exponent is the 1/3. He gets exiled. Please pause the video and get the last 2 of these written from exponential form into log form. Log base 4 of 2 equals 1/2. Log base 125 of 5 equals 1/3. So we're switching from an exponential form into a logarithmic form. And then the very last concept for the old video, I guess I take that back, there's one more thing after that, is just evaluating an expression, a logarithmic expression. It's like, okay, log base 5 of 125. Here's the moral of the story. If we wanted to know what that was, we could turn it into this. It's like, I'd like to know what log base 5 of 25 is, so I'm going to call that x. And then, if I wanted to, I could change this equation from log form into exponential form. I take the base to this exponent equals 25. Sorry about that. Equals 25. And then this basically just says to me, 5 to what power is 25, dude? Well, that's the second power. These are all those perfect squares and perfect cubes and whatever that we've had you memorize. So since this is not your first rodeo with logarithms, this is 2 to what power equals 8. You know, 2 to what power equals 8? Well, that's got to be 3, dude. 2 to the 3rd power. It's definitely not 2 squared. 2 squared is 4, so 3 is what this guy turns out to be. That's it. That's the answer, 3. So this one, when it's log base 7 of 49, it really says 7 to what power is 49? That is 2. And here, 9 to what power is 9? Well, that is a 1 in that case. So I'll do a couple more with you. 3 to what power is 27 is what this really means. 3 to the 2nd is not 27. 3 to the 3rd is 27. 5 to what power is 125? Well, that would be also 5 to the 3rd. I guess I just need the 3, so that's what we're rocking in that case. Didn't need that. Log base 8 of 64 is how you actually read this out loud, but what it means is 8 to what power is 64? That is a 2. And 2 to what power is 16? Well, that is a 4. Why don't you try these 4 problems on your own? It's just basically 13 to what power is 169, and etc. Please pause that video. So 13 to the second power is 169. 10 to the third power is 1,000. It's how many zeros this number has. It has 3 zeros. Well, this one, it's definitely not 9 squared, so it's got to be 9 cubed, is 729. And 3 to what power is 243? Well, 3 to the second is 9. 3 to the third is 27. 3 to the fourth is 81. So 3 to the fifth is 243. 243. So cool. What we're going to do is I'm just going to skip through the rest of these. We're going to talk much more about it next time, and I want to go to 31. So if you would just kind of skip right on along. They say evaluate each logarithm to the nearest 10,000th. Those all were common logs that we did, those LOGs. Now it's time for the natural log. If you remember, the natural log has the base e. On the first few problems, they just ask us to punch these guys in and round them to the nearest 10,000th, which is 4 decimal places. Sorry that my calculator keeps messing with me here. But I just need to hit the natural log button, which is right here to the left of the number 4. So if you can't see that, it was about right here. That didn't work the way I wanted it to. Come on. Sorry, guys. So the natural log of 12,492. Hit equals, and let's round that to 4 decimal places. So that is about 9.4328. So about 9.4328. We can just punch this guy in right here to be the natural log of 943. Then we've got to close that parenthesis minus the natural log of 181 and close the parenthesis because it automatically starts that guy out. And to round that to 4 decimal places is 1.6506, so about 1.6506. And then finally multiply those together. You can just punch that in. It's the natural log of 931, close the parenthesis, times the natural log of 32, close the parenthesis, and get about 23.6927. 23.6927, and it was approximate. So that's just punching them in. Now they say write a log equation with the equivalent. This is just what we did on the first one. We want to change it from exponential form into log form. Whenever e is the base, baby, that's when we will use a natural log. So you know how we brought log into it before? We're going to use the natural log. Yes, e is the base, but we don't need to put it down there. It is understood that e is the base, so you don't need him. The argument is 7. And the exponent gets exiled of 2x. So since e is the base right here, I will use a natural log. The argument is 10x, and that equals the exponent. The exponent gets exiled. That was going from exponential form to log form. A lot of people get confused with e's, and they think that is a logarithm. There's only 2 types of logs, the log and the ln, for logarithm de naturale. That's the crazy way to say that. So write each log in exponential form. Remember, little e is the base on this guy, so we're going to take the base to this exponent, 0.3345, and that will be approximately the argument, since they use an approximate sign. Here, e to the exponent equals 42. So I will let you guys try the last few there. Change it from either like exponential form to log form or log form to exponential form. Give it a shot. See what you think. Natural log of x equals 15. Remember, e is the little base, but you don't need to put him. The natural log of 45 equals 3x. This is in log form because it's already got a log, so e to the x equals 20. and this is in log form, so remember the base is e to the 8th equals x. It is amazing on MyMathLab how many people can't type natural logs in, right? They think that is a capital I. It is not a capital I. It is a lowercase l and a lowercase n for natural logarithm. Logarithm de natural, which is the Greek way to say it. So, all right, get your little MyMathLab assignment a try and let us know if you have any questions. Have a good one.